All right. So my name is Zein Al-Atrache. I'm a PGY2 neurosurgery resident over here at the Philadelphia College of Osteopathic Medicine. Today I'll be talking a little bit about the research we've been doing entitled Utilizing GFAP-Specific Aptamers for Rapid Identification of GBM. So I have no financial disclosures. So as most of the audience members know, we have a huge challenge in neurosurgery to optimize the extent of resection of GBM. Fortunately, we do have lots of anatomy-based guidance systems and fluorescence-based guidance systems that have been expanding quite a bit. Intraoperative CTs and MRIs have been actively used since the 1960s and 1980s, respectively, and also neuronavigation systems have advanced pretty significantly. Now, unfortunately, all of these image guidance systems are plagued by tissue edema that surrounds GBM and other similar lesions, and unfortunately can be led less accurate by intraoperative brain shift that can occur in or cause about 1 centimeter of shift, and with the navigation systems itself have its own margin of error with up to 2 millimeters. There are lots of fluorescence guidance systems that have also been advancing, including the use of antibodies for ex vivo applications, immunogenic applications, and unfortunately it can be very time consuming and can have a significant effect on the immune system that you ideally would not want to have intraoperatively. Multiple fluorescent dyes have also been used and explored, including 5-ALA, fluorescein, ICG. 5-ALA has been used more often and unfortunately is also plagued by poor specificity, especially in differentiating tissues with moderate dysplasia versus cells with inflammatory changes, and in the broader context of normal tissue. ICG is great for evaluating arterial and venous anatomy. Hemangioblastomas, meningiomas, sinus thromboses are all very great applications for this, but they require such high doses and oftentimes are nonspecific in terms of their labeling when the blood-brain barrier is disrupted. Fluorescein has also been used frequently, and unfortunately there are such high variations in the dose and timing of administration, and sometimes they can interfere with other factors such as a blood-brain barrier that's also disrupted. So that brings us to the technology that we've been using, which are aptamers. So aptamers are DNA or RNA-based, even peptide-based molecules that can be customized in terms of their construction and tagged with varying molecules. In the case of our GFAP-specific aptamer, Psi5, which is a fluorescent molecule that lights up red when exposed to certain wavelengths of light, especially under confocal microscopy. So ideally, the aptamers that we've designed with the help of Aptogen have allowed us to recognize GFAP or glial fibrillary acidic protein, which are highly expressed in astrocytoma cells and not in other tumor types such as lymphoma, which are often on the differential of GBM. So aptamers allow us to utilize very specific labeling in multiple different pHs, temperatures, ionic conditions. They're less expensive to synthesize, and they're a lot less variable post-synthesis since they're highly purified. Furthermore, in contrast to antibodies, they're also a lot less immunogenic. So our experiment, we were able to, again, with the help of Aptogen, a company based out of Pennsylvania, design aptamers that are tagged with Psi5 molecule and that can pass intracellularly within astrocytoma cells, recognize GFAP, thereby labeling GBM tissue in the broader context of normal tissue that ultimately will allow us to identify astrocytoma cells, astrocytoma versus lymphoma, lymphoma being our negative control in our studies, astrocytomas being our positive control. This will ultimately allow us to streamline tissue sampling and optimize resection. So we conducted these studies by aliquoting very small amounts of our aptamer at the concentration of 400 nanomolar into an in vitro model using U251 astrocytoma cells, in contrast to Ramos lymphoma cells as our negative control, because ideally these lymphoma cells don't express GFAP, versus the astrocytoma cells which highly express GFAP. And after only about 20 to 40 minutes of incubation, we're able to both quantify the fluorescence of the bound GFAP specific aptamer, qualitatively assess them, because ultimately at the end of the day we'd want to use this type of technology intraoperatively, so we have to visualize the changes in fluorescence. And then of course utilize tissue samples, actual GBM tissue samples, to validate the in vitro studies we were using. So first let's talk about the quantification of fluorescence. So these experiments we conducted were accomplished using flow cytometry. So in each one of these scatter plots, every single dot is a cell, and in analyzing samples with hundreds of thousands of cells, we're able to gather these scatter plots on the x-axis being their side scatter, or essentially size, and then the y-axis versus the x-axis being the quantification of Sci5 fluorescence. And as we see in each one of the quantified cells, the degree of Sci5 fluorescence, especially in our U251 astrocytoma cell population, is significantly greater than that of our Ramos lymphoma cells, indicating to us that this GFAP-specific aptamer is making its way into our U251 astrocytoma cells at a much greater degree than our Ramos lymphoma cells. Now we can represent this data in multiple ways, and this is on the left side. One way we can analyze this data is using these histograms. Now also on the x-axis, the degree of Sci5 fluorescence is quantified. We see again U251 astrocytoma cells taking up this aptamer and retaining it at a greater degree, greater frequency and amplitude than Ramos lymphoma cells. We've been able to replicate this in two additional aptamer types, and each representing a significantly greater fold difference, 3.4, 2.3, and 1.5 in each of our separate aptamers, resulting in a significantly greater amount of fluorescence in our astrocytoma cells versus our Ramos lymphoma cells. In terms of assessing their fluorescence qualitatively, we've been able to show, again in multiple replicates, that our GFAP-specific aptamer bind to, and we can recognize this greater degree of fluorescence in our U251 astrocytoma cells, in contrast to our negative control, these Ramos lymphoma cells. So we can actually visualize this significant increase in fluorescence. Unfortunately, we have yet to utilize our in vitro studies, translate our in vitro studies to tissue samples, but that's the next step. Hopefully we'll be getting to soon. To summarize, we've been able to quantify this fluorescence. Again, this data is just now coming out, and we've been able to demonstrate that there's an upwards of 40% greater fluorescence in the Sci5 fluorescence of our GFAP expressing astrocytoma cells versus our lymphoma cells. We've been able to, in the future, we hope to confirm that aptamer GFAP binding is to the same sensitivity as that of other anti-GFAP antibodies, and therefore co-localize these relationships to demonstrate that our anti-GFAP aptamer works just as well as antibodies. Ultimately, we'd like to apply this aptamer to GBM tissue samples. So a lot of exciting work is going into this. Thank you so much for allowing me to present. I'll be happy to take any questions.